Looks like it. It says you are screen sharing. Okay, so if you got my email, I saw that he had posted a test. I guess he taught this in 2010. I did not know he had taught it before. I took this class in 2013. No. 2004. I don't know. 2014 maybe. And it had the same professor for a long time, so I did not know he had ever taught it. So we do have this test to go by. It was a different book back then, so I don't know, how similar it would be. But I thought, this would be a good kind of idea to see what sort of questions he might ask, and they're very straightforward, which is nice. This is a very very straightforward test. If you understand the circuits, there's nothing tricky on here. But I will. So I thought I'd go over this one today, and then on Tuesday I will go over questions that are similar to the homework that y'all have had, in case he decides to put something on there that's more like the homework than more like this. So, before I get started, are there any questions? All right. So, one thing to keep in mind as I'm doing this is that with these kinds of problems, there are always multiple ways to do them. So there is not just one way to get to the answer. And so just because I do it one way does not mean that you have to do it that way. As a matter of fact, you'll probably get a whole lot of benefit out of trying to work it different ways and seeing if you get the same answer. And that's how I found, and still find, how there's something that I don't really understand really well. If I work it one way and I think I did it fine and I get one answer, and I work it another way and I get a different answer, but I thought that they were both correct, then that means I'm not understanding something somewhere. And so that can be a useful thing for you to take a look at. Okay, so like I said, these problems are really pretty straightforward. There's only a few concepts that you need to know to be able to do them. So for this first one, we have the information that the 4 ohm resistor absorbs 16 watts of power. So the first thing that you should know is that power equals IV. So we have the power, we have the resistance. We are supposed to be finding, part A says to find the current. A lot of times I don't necessarily look for what the problem is asking me to find. I just find everything and then fill in. But on a test, you have to be a little more careful with your time. So will the Tuesday session be recorded? Yeah, I will record it. It's a test review, so I will definitely record it. There are like 3 different versions of the power formula. You only need to, has he said anything about a formula sheet?
I think the test is open book.
Test is open book. Oh, wow.
Or open note, at least.
Open notes. Okay, well then you don't need to worry about memorizing anything. But I can never remember the different forms of the formula because it's so easy to derive the other ones. So P equals IV and V equals IR. So then I could say that P, just plugging this in for V, P equals I squared R. So knowing that the 4 ohm resistor absorbs 16 watts of power, then I can say 16 equals I squared times 4, with 4 being the 4 ohms, or 4 equals I squared, or I equals 2 amps. So that's part A. And then the source voltage Vs. Okay, so now I look at the voltage and I have the current. Everything is in series. This is just one simple circuit, just with everything in series. And so the same current goes through everything. So I can use Ohm's law and say V equals IR. Now I need to get the resistance for the entire circuit. So this voltage source, that's the change in voltage from before the voltage source and then all the way around to the other side of the voltage source. So I need the resistance for that entire thing. They're in series, and so the equivalent resistance for the entire circuit is 6 ohms. And so V equals 2 amps times 6 ohms, or V equals 12 volts. Alright, and then that was part C, sorry, and that's C. And then part B says to find V1. Okay, so V1 is the voltage across a particular resistor. So to find V1, I've got the plus side and the minus side. I want the current going in the direction from the plus to the minus. Well, I have that. That was 2 amps. And then once I have that, if I have the current going across the resistor from the plus side to the minus side, then that's Ohm's law, V equals IR. This is the change in voltage across that resistor. So it'd be 2 amps times 2 ohms, or V equals 4 volts. So, or V1 equals 4 volts. So that is the voltage change across that 2 ohm resistor. Now that I have done part C, and I know that my total voltage, my voltage source is 12 volts, it doesn't ask, but if I did want to find, say, plus, minus, and we called this V2, the voltage across that 4 ohm resistor, V2 would have to equal 8 volts for my entire circuit. And then D, the power supplied by the source, well, I'll go back to the very first formula I used, P equals IV. I know the current through the voltage source is 2 amps because I have the same current everywhere, because everything is in series. I know the voltage across it. I solved for that in part C. That's 12 volts. Now, if I wanted to assign a sign to it, the current is coming into the negative side of that, so that would be a negative 12 volts. So the power is negative 24 watts. But when you answer the question, the power supplied by the source, you don't put the negative in there. You would just say the power supplied is 24 watts. Now, if you had gotten a positive number, that would mean the power wasn't being supplied, that the power was being absorbed. And so if I'd gotten P equals positive 24 watts, that would mean the power absorbed is 24 watts. Okay, so that was question 1. Any questions on that one? All right, so y'all need to make sure you ask questions if you have them.